So far, all the magic number problems we've been doing have had three terms in them. There's been that x squared term, the x term, and our constant. Certain problems can still be factored using magic numbers, even though they're lacking one of the three pieces. In both of these problems here, our b term, our b is 0 in this problem because our x term is not present. And at first it looks like I don't even know how I would do factoring on that because we're missing that piece. But you can rewrite your problem as x squared plus 0x minus 25, and then you can do your magic numbers just like normal. So I need two numbers that add to 0 and multiply to negative 25. Well, if they have to add to 0, they have to be opposites of each other. And two opposites that multiply to negative 25, it's going to be 5 and negative 5. If you do 5 times negative 5, you get negative 25. If you add them, you get 0. So I'm going to write down my problem here as x squared plus 5x minus 5x and then minus 25. And when you go through and you do the whole factoring process, you'll end up with x minus 5 times x plus 5. So initially it looked like it wasn't going to be a problem that we could use our rules for, but by putting in that 0x for the missing term in the middle, we just did magic numbers like normal. It's very much the same process for this one here. You need two numbers that add to 0 and multiply to negative 49. Because it's like I put x squared plus 0x minus 49. And when you go through and you do the math, you're going to end up, well, this one the numbers are 7 and negative 7. Trying to speed through the work here, but you just factor it like normal. And you will end up with x plus 7 times x minus 7. This leads me to a rule that I'm going to tell you guys that'll make certain factoring problems easier to do. It's like a little shortcuts. And our factoring rule is for the difference of two squares. You'll see this abbreviated DOTS, D-O-T-S, difference of two squares. Difference means we're subtracting, like right here or right here, of two squares. Squares are numbers that have nice square roots. So the basic rule is if you have some random thing, a squared minus b squared, so some number squared, some number squared, this is going to equal a minus b times a plus b. So I'll show you how that works out on the problems above. If you look at that top left problem here, I have x squared minus 25. You can think about that as x squared minus, but instead of writing 25, I'm going to write down 5 squared, like that. It's the same thing, because 5 squared is just 25. Well, according to our rule, the first parenthesis is going to be just the numbers underneath the exponent. So I just do this minus this, so x minus 5. And in the second parenthesis, I'm going to do this plus this. So I do just x plus 5. And I got the answer without having to do any of the factoring process, magic numbers and all that. If I do it on the other problem here, I had x squared minus 49, but instead of 49, I'm going to write a 7 squared. According to this rule, that's going to factor into x minus 7 times x plus 7. It's not a trick that works all the time, but it's kind of handy when it does, if you can rewrite it. If it wasn't possible, like if this was really like a 19 here, something that didn't have a nice square, you just don't use this rule. It won't factor nicely. One more problem that's maybe a slightly tougher, just so you guys can see why this might be useful. Let's say we had 9x squared minus 16. If you look at this problem here and you think you could do magic numbers, that'd be fine. But if you realize this is really 3x squared, because 3x times 3x is 9x squared, minus 4 squared like that, your answer is just going to be 3x minus 4 times 3x plus 4. So it's a nice little trick. It won't always work, but when it does, difference of two squares is very helpful.